All right, doing this problem called maximum bags with full capacity of rocks. Let's have a read. You have n bags numbered from 0 to n minus 1. You are given so there are n different bags, okay? You are given a zero index integer array capacity and rocks. The ith bag can hold a maximum of capacity I and rocks, and the currently contains rocks of I rocks, okay? You're also given an integer additional rocks, the number of additional rocks you can place in any of the bags. Return the maximum number of bags that could have full capacity after placing the additional rocks in sub bags. Let's look at an example. This is the capacity of each bag, and this is currently the rocks that they are holding, and I have to put two additional rocks. So this I can put one here, I can put one here. So I'll get three rocks with full capacity. But hold on, yeah. So no. Yeah, so I could put if I make one plus one two, two plus one three, four is already at. So there are three bags which are just one less than the full capacity. So any of those two will get this and will get to full capacity. Place one rock in bag 0 and one rock in bag 1. The number of bags in each bag are now this. Bag 0, 1 and 2 have full capacity. There are 3 bags at full capacity, so we return 3. It can be shown that it's not possible to have more than 3 bags at full capacity. Note that there may be other ways of placing rocks that result in an answer of 3. Correct. Example number 2, let's see. Example number 2 has stand 2 and 2 and rocks are 2, 2 and 0. And additional rocks are 100. 100 is too much, right? Okay. So I put 8 here, I put nothing here, and I put 2 minus 0. I put 2 here, and all three bags will get the full capacity. So it's very simple. Though the rocks array that's there, I'll convert this rocks array into the subtract capacity. So capacity minus rocks. That's so these many rocks I want, and then I sort that, which will tell me, hey, these are the rocks which require minimum bags, right? To be greedy, essentially, if you want to maximize the number of bags with maximum capacity, with which are full capacity, I'll add rocks to the bag which requires minimum number of rocks, right? So it seems quite basic. So essentially, I'll do I'll change the rocks array to the uh, to the required extra rocks. So for int I equals to 0, I is less than rocks dot length I plus plus. What I'm gonna do is rocks of I equals to capacity of I minus rocks of I, right? So this is how many extra rocks it wants to be at full capacity, and then I'm gonna sort this. So arrays dot sort rocks, and now in this sorted array, this is a sorted array. I'll keep on adding additional rocks from it, right? So now I'm gonna go for I equals to 0, I less than rocks dot length I plus plus. If uh, rocks of I equals to 0, then I'm gonna do let's do the count, right? So I'll say my count is 0, and all the rocks which reach full capacity. This is another condition that I have is and additional rocks is greater than 0, right? No. First, you might not have addition of 0, but there might be some rocks which are at 0, right? So yeah, you use break. But okay, so this is the case, then you do count plus plus, and else in the else you do if additional rocks is greater than or equal to the rocks it requires, then you're gonna do uh, additional rocks additional rocks minus equals to rocks of I, and then you're gonna do again count plus plus. And if that's not the case, then now from this rock and next rock onwards, the number of rocks that are higher than the remaining additional rocks I need to break. And here you do return count. Okay, that's submit. Man, it works with a decent percentage of beat, like it beats decent number of solutions as well. So it should be good. All right.